Okay, this is section 17, group problem 2. So we are going to solve this numerical. So basically what we need to find out is we need to find out the mass moment of inertia of this compound shape. So this wheel is basically consisting of two rings. So you can see the first ring is over here. So this is our first ring and this is our second ring. So you can see that there are two rings over here and we need to follow the dimensions are given over here. And not only two rings, but there are 8 rods as well. So you can see there 1, 2, 3, 4, 5, 6, 7, 8. So total 8 rods over there. So this shape can be changed, but depending upon the information and the drawing, we have to see how it is. Okay, so this small ring has its own weight, the larger ring has its own weight, and the rods has its own weights. So the weights are given as the large ring has a weight of 100 pounds. Okay, so this one is 100 pounds. The smaller ring has a weight of, because it's given like corresponding, so the smaller ring is given the weight as 15 pounds. Okay, so we just write it on the drawing so it will help us later on and we'll see. And each of these rods are basically having their own weights and it is 20 pounds. So each rod is 20 pounds. We need to find out mass moment of inertia of this wheel about an axis perpendicular to the screen. So this axis perpendicular to the screen which is towards us when we are looking at this projection, the screen or over here. And not only this O point, but also this A point. So you probably can see this A point over here. So we need to find this about O point and A point, the mass moment of inertia. So how to solve it? So first we'll try to solve it with the each of the component, like inner ring, outer ring, or smaller ring or bigger ring, and these rods. Okay, so these are the formulas we have. So from the long list, we need these two formulas. So we are going to look at these two formulas. So first thing is first, for the rings, we need to find out the formula. The formula is about z-axis. So you can see that there are multiple axes. So this one is z-axis, this one is y-axis, this one is x-axis. So for the ring, because we have to find out the mass moment of inertia about the plane perpendicular to the screen, perpendicular to how it is being drawn. So basically, we are looking to have the mass moment of inertia about z-axis. So you need to go and see what is the z-axis formula. So you can see over here for x-axis and y, because it's symmetrical on that line, is half mr square. But for z axis is without half, is mr square. So we are going to use this formula. Why we are going to use this formula? Because we have to look at around z-axis perpendicular to the plane. Now coming back to these rods, because first we formalize or select the formula and then we are going to put the values in it. So you can see there are multiple axes. This axis about the center of mass is y-axis, this is x, this is z, and if you go to the end of it, it's y prime and x prime. So the different formulas are given for y x-axis, y is 1 over 12 mr is ml square, m is the length of it, and for the other axis we have this I y prime x prime is half m l square, and about I z axis the mass moment of inertia is 0 for this cylinder rod. Okay, so you see this is a cylinder rod. Which axis we have to take? Which axis we need to, because this is perpendicular to from the center of axis perpendicular out of the screen, so we need to find out of the screen. So we'll take I y or xx from the center of mass towards. You will see that I y and I xx is the same formula, and this formula is 1 over 12 m L square. 1 over 12 ml square. Okay, now we have done with the formulas, so we just write a generalized equation for this compounded shape. So we need to find out the I about the point O. So there are three distinct masses, so we need to write the formula for each of it. So we can write something like this, that the I of the, let's say, outer ring plus I of the rod plus I of the inner ring, IR. However, you should notice over here that there are 8 rods over here. So we must multiply this by 8 because there are 8 different rods. Depending upon the input data, it can be 4, it can be 5, it can be 6, something like this. Okay, we finalize the formula that we have to use IZZ and IXXYY for the rod. This is for the rings. Okay, so the formula would be M R square. This is outer ring radius plus 8 because we have to multiply by 8 with all of them. Okay, so multiply by 8, and the rod formula we selected was 1 over 12 m mass of the rod L square. However, something you have to notice over here, this formula is valid passing through the point G, which is the capital G is basically the center of the mass. So the center of mass for this rod is somewhere over here for each rod. We need to shift it from the center of mass to the point O. So we need to apply the parallel axis theorem. So according to the parallel axis theorem, for the mass moment of inertia, we have to multiply it, uh, the distance with the mass and add them. So it should be md square. And what is the value of that d? That d is from the centroid to this origin point. So this is the value of d we are looking. So what is the value of d over here? So you can see that it is the length of it. So we need to have to go to the center of this and add this value. So first we write the generalized formula and then we'll put the other value. Okay, and then the mr square, and this time it is inner ring. So we write the IR for both of it. Now we'll put the values. So what is the weight of the outer rod? The weight of the outer ring was 100 pounds. So we say 100 divided by, because you know that the formula for weight and mass is mg. So if you want to calculate the mass, it's weight divided by g, because it's the FPS system, foot pound system. So we multiply by the value of g like this, 32.2 feet per second square. So we multiply it by that so that it will convert into slug, and we write the units later on. And then if you look at the radius of this outer ring, it is 4. So you can see it over here, it is 4. So we just write 4 or multiply by 4 plus 8. This 8 is basically representing that there are 8 rods. It's not a part of the formula. 1 over 12, the mass, or we need to write the mass of each rod. So we need to divide the weight of each rod. The weight of each rod, as you can see over here, we just write it over here to avoid confusion. It's 20 divided by 32.2, and the length of each rod. How much is the length of each rod? So you can see the 4 is the outer radius, and for the outer ring, and 1 foot is the radius of the inner ring. So it should be 4 minus 1 square plus the parallel axis theorem. Okay, so again the mass, because we are writing the mass of each of it, and 8 will take care of the rest of the masses. D. So how much is the value of this D? So you can see that the length of each rod is 3. We just calculated over here. So the length of each rod, if we want to calculate the length of each rod, it is 4 minus 1 equal to 3. So if you want to go to the center of it, it should be 3 divided by 2. Okay, so 3 divided by 2, it's this distance from the center, and then you need to add this one radius over here, so plus 1. So you can say the D value is basically 1.5 plus 1, 3 divided by 2 is 1.5, is 2.5 fit the D value. So we'll go over there and we write it the value over here, 1.5 plus 1 whole square. So this is the D value we have. So we completed with the rod, and the last part is to look at this inner ring. Okay, so the mass of the inner ring is 15 pounds. Again, divide by the value of G. Okay, multiply by radius. The radius of this is 1, so we just multiply. So we got 3 terms now. Okay, each representing, this is representing the outer ring. This whole with the value of 8 is representing the rods, and this third term is representing the inner ring. You put the numbers into the calculator, and when you crunch the number, you'll get the value of mass moment of inertia about 0.0 for this compounded or compound structure. Okay, so this is passing through the center of it, perpendicular to the plane which we are looking at. Okay, now we try to find out the mass moment of inertia at point A, because we just found out the mass moment of inertia about point O. So for this part B, which we have to find out this about point A, is use the same formula. That formula is parallel axis theorem. So if you want to find out about any specific point, let's say A point, would be equal to the mass moment of inertia at the centroid of the compound shape plus md square. So what is the d over here? The d over here is from this point O to, we need to go to this point A. So this is the d now. So what is the value of this d? So you can see it is 4 over here. 4 is the radius from the center to it. So this value is basically 4p. What is the mass over here? The mass is total mass. Okay, this is where you can perform a mistake, because you need to see how many components are there. There are 2 rings, 8 rods. So we need to talk about a total mass over here, and we do not need to miss this. And I naught is the value which we previously calculated. So all we need is to just put those values. Okay, so I naught remain I naught, which we calculated as 89.94 in the previous step. Then we have to do the mass. Okay, so for the mass, we have 3 things. The first one is the outer ring. Okay, so the outer ring was 100 pound plus the rods, with each rod is, as you can see over here, it is 20 pounds. But must remember, don't forget it, that this has to be multiplied by 8. Why? Because we have 8 rods plus 15, which is the mass of the inner ring. This is mass. Sorry, this was a weight, so we need to divide by 32.2 to convert it into mass. So altogether is the total mass. So make sure, don't forget to multiply it by 8 number of rods. Okay, so these rods can be 5, 6, depending upon the diagram or whatever the input data is given. And this d distance, as we calculate, it's 4. So multiply by 4 square. So all you need is to just crunch these numbers, and when you do these numbers, so it will turn out to be 222. This is the mass movement of inertia at point A, and in the previous step we calculated the mass movement of inertia about point O, which was the value was 189.94. Don't forget to write the units, which is slug, which is a mass unit in FPS system, and fit square. These are weights, okay, so you can see each of it is basically the weight over here. And you have to convert these weights into mass, and this formula, we know this thing, that the formula is very simple, W equal to mg. So if you want to calculate the mass, would be equal to weight over g. And the g value is 32.2 fit per second square for the FPS system.